Lesson 2 on calculus. In this lesson, we need to find the turning point of this function, as well as determining whether it is a local maximum or a local minimum. Please subscribe, like, share, and comment. Now, to find the turning point of this curve, we need to find the derivative of this function. So we are differentiating y with respect to x. So we say dy dx is equal to 9 minus 3e to the power minus 3x. And dy dx is equal to 0 at a turning point. So we shall equate that to 0. So we say 0 is equal to 9 minus 3e to the power minus 3x. Now we take this to the other side of the equation. We have 3e to the power minus 3x is equal to 9. We divide by 3 on both sides of this equation. We have e to the power minus 3x is equal to 3. Then we take logarithms on both sides of that equation. So we have ln and ln on that. And you know, with the properties of logarithms, we say ln e to the power a is equal to a. So we shall use it on that part. Then we say minus 3x is equal to ln 3. We divide both sides of that equation by minus 3 by minus 3. Then we say x is equal to minus 1 over 3 ln 3. Now we need to find the corresponding value of y. Now we shall take this x into the original function to find the corresponding value of y. Then we say now y is equal to 9. There is x minus 1 over 3 ln 3 plus e to the power minus 3. X is minus 1 over 3 ln 3 into minus 1 over 3 ln 3. Then we say y is equal to, you multiply this and that, you're going to get minus 3 ln 3 plus e to the power ln 3. This cancels off with that, the negative and the negative, you get a positive. And now another property of logarithms, it says e to the power ln a is equal to a. So we shall use that on this part. Then we have minus 3 ln 3 plus 3. That is the corresponding y coordinate. Then we say the turning point of that function is given by the value of x minus 1 over 3 ln 3 and the y part of the coordinate minus 3 ln 3 plus 3. We have found the turning point of that curve. Now, part B, we need to determine whether it is a local maximum or a local minimum. Now, to do that, we need to find the second derivative of that function. And d squared y dx squared, when it is greater than 0, we have a minimum turning point. We have a local minimum. And if we have d squared y dx squared, the second derivative, less than 0, we have a local maximum. So we need to find d squared y dx squared, the second derivative. You remember we have dy dx is equal to 9 minus 3e to the power minus 3x. Then we say d squared y dx squared is equal to minus 3 into minus 3e to the power minus 3x. If we differentiate that again, then we have 9e to the power minus 3x. Now we need to substitute the x value of that turning point into that. Then we say at that turning point, d squared y dx squared is equal to 9e to the power minus 3 multiplied by x, the x value, which is minus 1 over 3 ln 3. And that is going to give us 9e to the power ln 3. These cancel off, and we use again that property of logarithms of exponents right here. Then we say that second derivative at the turning point is given by 9 multiplied by 3. And that gives us 27. And this is greater than 0. Therefore, we say we have a local minimum. We have come to the end of this lesson. Thanks for watching. Please subscribe, like, share, and comment. Enjoy your day.